Hello, this is question 7 on your mix exercise 3 from year 12. You have the curve and the line given by this equation. So this one is the curve, this one is a straight line, where k is a non-zero constant, intersect at a single point. Find the value of k. If we have to find the intersection between these two lines, what we are going to do is solve simultaneous equations. And we can, for that, make x or y the subject in the linear one and substitute in the other. And that's what I'm going to do. And then we are going to see what we can do to make them to intersect in just one point. So I'm going to make y the subject because it's easier than the x, but you could do the x. In these questions, you can do either the x or the y, doesn't matter. The one that is simpler. So I have made in the second one y the subject. And what I'm going to do now is substitute the y by that expression. So I'm going to have k x squared minus x, and instead of y, I'm going to write that. I'm going to substitute by that. Then plus k plus 1, x equals to 1. I'm going to expand the brackets. So this bracket here, and I'm going to reorganize because what I'm going to have is a quadratic in x. So k x squared minus x minus k halves x squared plus k plus 1 x minus 1. I'm bringing the 1 to this side. So now I'm going to collect like terms. So I'm going to simplify this expression, and I have k minus k halves is k halves. So I have k halves x squared. Then I have minus x plus k plus x. So the x and minus x are gone, and I have kx, so plus kx, and then minus 1 equal to 0. This is a quadratic, this is A, this is B, and this is C, together with the minus. So what I'm going to do to make this quadratic to have one solution, intersect at one single point, means that this quadratic has only one real solution, is the discriminant must be equal to 0. So the discriminant is going to be 0, which means b squared is k squared minus 4 times a times c. The minus and the minus becomes plus. This times k halves and times 1. So this must be equal to 0, which means k squared plus 2k is 0. If I factorize, I have k plus 2 equal to 0, which gives me two solutions, k 0 and k minus 2. Yeah, just making each of the factors equal to 0. They say it's a non-zero constant. Yeah, so the only other value of k is going to be minus 2. So this, the first one, this one, no, is non-zero constant. So this constant, this cannot be. Yeah, so k is going to be minus 2. Then for b, give the coordinates of the point of intersection of the line and the curve. So now that we know our value of k, which is this one, is minus 2, to find x, we are going to solve this equation. Yeah, and we are going to find that there's only one value, and if not, we are in trouble. Yeah, it's something we've done wrong. So k is minus 2, minus 2 divided by 2 is minus 1, so I have minus 1x squared, then minus 2x minus 1 equal to 0. I'm going to change the sign of everything, so I have a nicer thing. And I'm going to factorize. If I factorize this, you are going to see very quickly that is x plus 1 times x plus 1, or x plus 1 squared, which means my solution is going to be x equal minus 1, and it's going to be double. So I have only one solution. This is the value of x. They ask me the coordinates. Give the coordinates, so that means I have to find y, but I know y is given by this expression, so I'm going to go back. I can substitute the x here or here, and this one is easier, so I'm going to find y. Y is going to be 1 plus, we say that k is minus 2 divided by 2 is minus 1, so minus 1x, and x is minus 1, so I have 1 minus minus 1, 2. So the coordinates are going to be minus 1, 2. That's the point of intersection. Yeah, and that's all with this question.